We are in the home stretch for Unit 4 physics students as we wrap up our discussion of non-free fall with another question. So consider a heavy and a light person jumping together with same size parachutes from the same altitude. Which person is going to reach the ground first? The light person, the heavy person, both at the same time, or is there not enough information? Pause the video now as you determine your answer. And the correct answer is the heavy person. Now, they both have the same drag force for the same speed. The heavier man has a greater downward force than the woman, and so the man has to drop farther to receive drag force equal to his downward force. That gives him a higher terminal velocity. Now, let's actually sketch this out. We're going to draw a diagram that represents the weights of the different people as well as the air resistance that each person experiences. First, we have the weight of the man, pointed downwards, since it's a force vector that is indicating direction and magnitude. Let's draw that again. So this is the weight of the man. Now we have the weight of the woman, which is not quite as great in magnitude as it is for the man. Slightly smaller magnitude. Now we have the force of air resistance. The air resistance for the woman, represented by the black arrow, the magnitude of that drag force, is going to cancel out the force of her weight faster than it is for the man. At the same moment in time, that's air resistance acting on the man, and it doesn't quite cancel out the magnitude of his weight. So the woman stops accelerating at this point in time. She's no longer accelerating and she has reached her terminal speed. But the man continues to accelerate here because the force vectors do not completely cancel each other out. He continues to accelerate and therefore he's going to reach a higher terminal velocity than the woman is. Note that a key point is that the man and the woman have same size parachutes, which means that they are going to experience an increase in, or they're going to experience the same type of air drag as each other because they have the same frontal surface area. Here is a related example. When you have a coin and a feather falling together with air present, if you release them at the same time, the feather is going to reach its terminal velocity much faster than the coin does. So it will, once it reaches its terminal velocity, it will fall slowly at a constant speed, and it will reach the bottom much later after the coin does. The coin, however, does not achieve the same sort of air resistance as the feather. Rather, the air resistance doesn't build up to its weight. It doesn't cancel its weight out, and so it's going to continue to accelerate and to continue to gain speed, thereby hitting the bottom much sooner than the falling feather. So, another question for you. If I remove the air from that tube by a vacuum pump, and the coin and feather activity is repeated, which is going to hit the bottom first? The feather or the coin? Or will they both reach at the same time, or not enough information? Pause the video to determine your answer. And I hope that you realize that both are going to drop together side by side. As I've emphasized throughout the year thus far, objects of different mass in a vacuum will actually fall at the same rate. As you can see here in this picture, when they fall in vacuum, there's no air resistance, and therefore they fall together. And with this virtual demonstration, that brings us to the end of our unit on Newton's second law. Congratulations for having gotten this far.